Hello friends, welcome back. Today in this video tutorial, we'll see what is DevOps and why should you learn DevOps in 2021. In the current IT market, there is a high demand on cloud, DevOps and automation. So mostly people are thinking DevOps is a technology or is a tool to learn to become a DevOps engineer. No, that's not correct. Okay, so DevOps is a mindset towards the automation. It's an approach how you automate your daily tedious stuff. Okay, so I'll show you the complete picture of DevOps and how you can choose your path and how you can use your learnings and how you can choose right tools to get your automation journey start. Okay, so before moving forward, if you have not subscribed my channel, please do subscribe so that you'll get notified when I add more videos on this DevOps. Let's think about a real lifetime scenario. If we go 40 or 50 years back, people used to travel by bullock carts from one location to other location. Then came the bicycle, then scooter, then car, and then aeroplane. So if you see all this progress, innovation and automation done to solve a problem, that is communication, how fast and comfortable we can travel from one location to other. So similarly, in software or IT industry, every day a revolution happening, and you will find there will be always new innovation, technologies and automations being done to solve the problem and easy our tasks. So let's discuss what is DevOps and the use cases. So DevOps is a software development approach which involves continuous development, continuous testing, continuous integration, continuous deployment and continuous monitoring of the software throughout the development lifecycle. So it's a collaboration work between development and operations. So if you think it's actually a culture to follow, and it's a mindset and the approach towards the automation, how we can solve the problems and how we can easy our daily tedious task and make it more comfortable and deliver the things on time. So we use various tools to perform and streamline the automation process. So there are different stages of DevOps. If you see, first is your version control, that is source code management. It's to maintain your codes in a repository with different versions. Okay, and then comes continuous integration, where you continuously build your application and your projects. Okay, so what it does, it compiles, validate code reviews, unit testing and integration testing is done in the continuous build stage. And then comes continuous delivery, where you deploy your application to a test environment, staging environment and perform your UAT on testing. Okay, that's continuous testing. And then comes continuous deployment, so where you deploy your applications or product to a production environment, that production release. Okay, so in this phase, what do you do? Configuration management, it comes containerization, how to containerize your application and all it, how to deploy into production, everything comes under continuous deployment. Okay, so here are the various tools in the complete lifecycle of softwares. If you see, for planning and coding, we use different softwares like Jira and Git, Subversions. Okay, and for build, we use Maven, Gradle, and so for testing, there are Selenium and JUnit. And for entire integration and build management, we use Jenkins. For deployment, we use Docker, Vagrant is there, Puppet, Safe, Kubernetes, Ansible, SaltStack. So these are the different tools from different companies to do the deployment stuff. Okay, continuous deployment. And for continuous monitoring, we have different tools as well, like Nagios, Splunk, or ELK stack. So these are the tools being used in different stages of the software life cycle. Okay, so let's see what is the software development life cycle before and after the DevOps. If you go back and see the traditional waterfall model, you'll see how the approach was there, like requirement gathering and analysis was when there is a requirement comes, it needs to be no, analyzed by your architect team or by the designer, and it comes for the designing stuff, like how the codes can be designed and what are the resources required, and all this comes in design step, and then it comes to the development, and then testing, and then deployment, and then maintenance. Okay, so here this approach, if you see, one by another, one step has to complete first and it will has to go to the next step. So it takes more time to reach to the final stage to deliver the product. It takes lots of time to deliver a product to a client, has lots of difficulties. If you see the limitations of waterfall model here, if you see, once an application is in the testing stage, it will be very difficult to go back and change something that was not well thought. That means in the design phase, if it is not designed properly, okay, so you cannot take back to the designing stage again. Though you can take it, it will be very difficult to come back again with changes. So it will take lots of time, and it will take lots of resources. So again, no working software is produced until late during the life cycle. So it takes lots of time, and we cannot deliver a working software like a final product, okay, the end of the life cycle. It takes lots of time. Also, it takes high amounts of risk and uncertainty, and it's not a good model for complex and object-oriented projects. Also, it's not suitable for the project where requirements are at a moderate to high risk of changing. If the requirement keeps changing, this model is a complete failure, because if a product is almost delivered, and in the QA phase, if it is we got some bugs and it needs to be fixed, or there is a problem with the design and that particular module is not working, what has to be done? The entire project has to be go back to the developer, and developer has to work on that, and it again will come for the testing for the tester. They'll do the testing, and it takes, in this process we consume lots of time, because if you know, in the project delivery of a software, client expectation is the most priority. Okay, so we have to deliver the product on time, on agreed time. Okay, and then so it comes the Agile methodology. What is Agile methodology? In the Agile methodology, each object is broken off into several iterations. That means the entire project, we don't have to work. The entire project will be converted into modules, some chunks. Okay, then each team has to, or each member has to work on each modules and deliver that module for the testing, and then each iteration it works. Okay, so what it says, all iterations should be of the same time duration, 2 to 8 weeks, or between 2 to 8 weeks or 2 to 10 weeks. Okay, at the end of each iteration, a working product should be delivered. So here we work in a module so that we don't have to dependent on the entire project to complete and do. If we finish one module, we can well before test it and to the send it for the quality check. Okay, here also some limitations also there for in Agile methodology. If you see, development team suppose wants a change, but the operation team, if you think about the operation team, they will be always thinking about the stability. They want their production environment to stable, right? So why is the problem? The problem here is, suppose a development team will be working on a development environment which is up to date. That means has a up to date version of a system. Okay, the system has upgraded to a newer version, but still the operation team will be working over the old versions. Okay, If the developer has developed something or changed something in the newer version, that may or may not work on the older version of the production environment. So once the code is delivered to the production environment, it will break. Okay, it will not work properly, but that was properly tested in the test environment or development while developed. So here what happens, there always a fight between development team and operation team. So to overcome this problem in DevOps, we use containerization, that is comes under a microservices. Okay, we containerize the application to make sure all environments, either it's development, staging or production, are equally set up, because the container, whatever you are going to use, will sit the same versions of your system, libraries, binaries, everything in the all environments. We'll more talk about this containerization in our Docker tutorial. I'm going to prepare it shortly. So how we can containerize our applications. DevOps is a collaboration between development and operation. So the developer and operation will collaboratively work in the DevOps model. Okay, so that's why when the code is delivered or deployed into productions, will be the same as the code was written and tested in the development environment. Okay, so let's see what are the tools on high demand in the current market. So we have a Git for source code management, that is for code repository. Okay, so the next is GitHub, which is used for remote repository. You store your codes remotely. Okay, and then comes build management tool, that is Jenkins, that is for unit testing and QA and integration testing. We use Jenkins mostly for continuous integration it comes. Okay, and next comes Ansible, that's for used for configuration management and deployment tool. And next comes Docker. Here we do the containerization and containerize your application. Okay, next comes Kubernetes. So Kubernetes actually is a container orchestration platform where you can orchestrate your containers and your cluster management, your networks, everything you orchestrate. Also it does application deployment in microservices. Then comes Terraform. Terraform is a very good tool which is being used for configuration management as well as the infrastructure automations. Okay, so now let's see what is the complete flow and how these tools and where you can use these tools in your DevOps journey. Okay, and here is the complete flow of our DevOps infrastructure lifecycle. If you see here, the developer will be now writing the code and developing the project and saving the code into the local repository, and he can use a Git or Subversion. So once the code is ready and locally saved, can push that code to the GitHub, and GitHub is our remote repository where you can store your codes remotely. And once the code is pushed, it will be, then you can integrate the Jenkins tool to get the codes whatever is updated into the GitHub, and it will start building the code. Okay, if there is any error or any failures find while building or testing, the codes will be the notification will be sent out to the developer. Okay, then developer automatically fix the code or bug and send back again to the GitHub. So once again the GitHub will trigger an event, and that will be again come to Jenkins and build it. Then once the code is successfully built, the war file or the binary files, mostly the binary files, it could be your war file, jar file, YAR or library or .exe file. These files will be stored into an Artifactory. Artifactory, you can use different tools out there. You can use JFrog. Okay, these codes can be stored there, and from there you can set up the Ansible to pull those codes and deliver to the different environments. Okay, to staging or productions. You can deliver to staging or deploy into the production. Similarly, you can use the Kubernetes as well to deploy your codes into different environments. Okay, after this deployed into the After you deploy it into the production environment, the codes can be monitored, the applications can be monitored by different tools like Nagios or Splunk. So it comes under continuous monitoring, and this delivery happens well when we deliver your codes for staging. It comes under continuous delivery, and for the production deployment it happens continuous deployment. Okay, and this code writing and building, this comes under continuous integrations. Okay, so if you see here, all the codes being from starting from the developer and ending with the monitoring, it's all automated. Okay, you don't have to interfere anywhere. Once you do the setups, all the things will go smoothly. So here the delivery of a product will be faster. Okay, hope you understood what is DevOps and how you can use DevOps in your day-to-day life or in your work. If you have any doubt or any concern, if you want to learn more or know more on this, please do comment me in the comment section below. I'll try to make more videos on DevOps, and keep watching my tutorials. I'm shortly adding more videos on different tools starting from Git to Terraform.